Good afternoon, folks. My name is Jay Kumar, and I'm from Broadcom. Today, we are going to talk about three topics. Two of them are related to the SAI pipeline changes, and one is enhancing the FEC mode for the high-speed Ethernet ports. So I'm accompanied by Kishore from Google, and the third presentation is in a recording mode. We are going to play the video for that. So just to get started, in SAI, the logical pipeline defines the contractual agreement, which is for the data plane, and then the applications are written on top of it, which expects a certain deterministic behavior as defined by the pipeline. So anytime we add new feature in the SAI code base, if it impacts the pipeline, what we do is we also go ahead and enhance the logical behavior of the pipeline. So there are two features which we added in SAI. One is the stage of the ACL, and the other one is the MyMAC Table. So I'll briefly go over it at an overview level, and then in the detail, Kishore is going to give you much granular detail on that. So ACLs, if you see in the SAI pipeline, there are two ACLs which we talk about. One is the ingress stage ACL, which is sitting after the L3 lookup. And then you can take different kind of actions for the packets post lookup. You can change the next hop. You can take various cost kind of actions on that. And then there is an egress ACL table which sits in the egress pipeline. What happens that there is a need where some forwarding decisions need to happen based on the packet metadata, right? And in that case, we need to qualify those metadata early in the pipeline and get some results, get some actions. And those results are fed up into the subsequent stages of the pipeline. So that is the stage we talk about as a pre-ingress stage of the pipeline, and we will go in detail on that. So this is the pre-ingress ACL stage. This is in the logical behavior of the pipeline. This we will go in detail and talk about the use cases, what are the use cases, why we have added that. And just to highlight that this is extensible. Right now, we are solving certain use cases. And if there is a need, we can always enhance just by adding new qualifiers or the actions. The second stage, which is being added into the pipeline, is the MyMAC table. The MyMAC table sits very early in the pipeline, and essentially it helps to give pipeline a hint whether this packet which is coming in should be steered for L2 lookup or L3 lookup. And these two are the two most coarse granularity. We can actually take one more step and say that this is the MPLS packet, and this is the DMAC, which is for the MPLS processing, and actually push it into the MPLS processing. Right now, what we have done the steering only for L2 and L3 processing, not for other cases, but it's extensible. And the last topic which we will talk about is the enhancement of the FEC modes, and that's mainly for high-speed ports, so 400 gig and 800 gigs. So that's a new PAM FEC modes which are not present in the SAI. There is a first level of enhancements we have done, and we have to do more enhancements, which we will do as a follow-up. So with this, I will give the control to Kishore to go in the details. Thank you.
Thank you, Jay. Hi, folks. My name is Kishore, and I work on networking software at Google. As we look to supporting our use cases using the SAI pipeline, there were a couple of feature enhancements we needed. The first one being packet header-based VRF classification. So today in the SAI pipeline, when an L3 router interface is created, it's assigned a VRF. And when a packet ingresses on the port, and based on the ingress port and the packet headers, a router interface is derived. And from that router interface, you figure out which VRF you're going to use when you do the L3 destination IP lookup. So we felt the need for more flexibility in the VRF assignment, specifically to be able to use the packet header fields themselves to override the VRF that would have been derived from the router interface. One example use case could be that you can use the L3 DSCP field to treat high priority traffic differently from low priority traffic, even though they both arrive on the same ingress router interface. You could, for example, use more optimal routes and things of that nature. To do this, we introduced a new action in the SAI ACL action supported actions, and this was basically set the VRF in the packet metadata. We also introduced a new ingress ACL stage, which will be looked up before L3 lookup. And the VRF classification rules that we had in mind were things which we wanted to apply to the whole switch. They didn't have any port-specific fields to them, so we wanted this pre-ingress ACL stage to be bound to the switch. In SAI today, the ACLs have port bind point, ref bind point, and switch bind point, and we felt the switch bind point made the most sense for this pre-ingress ACL rules we wanted to install, especially with keeping in mind the scaling aspect. So this was the PR that we got merged in SAI 1.8. We essentially added an ACL stage called pre-ingress, which has a switch bind point attribute, and we added a new action called set VRF, and all the existing ACL match conditions sufficed for us. As Jay was mentioning, set VRF action is just a start. If there are more actions that make sense for this pre-ingress ACL stage, they can be easily added on. This is an example of how you would instantiate an ACL table with this stage and a sample rule that would match on a particular DSCP value and set a VRF ID. The second enhancement that we were looking for was the ability to program this MyMAC table. So today the router interface has a source MAC address attribute, and it is used in the ingress pipeline as well as in the egress pipeline. In the egress pipeline, as the name suggests, it's used to stamp the source MAC in the packet egressing that particular router interface. In the ingress pipeline, analogously, it is used to match against a received packet's DMAC. So essentially, if the received packet's DMAC matches the router interface's SMAC, it's destined for the router, and this packet thus needs to be L3 forwarded. We wanted to be able to program the MAC address in the ingress pipeline separate from having to create a router interface. And this would allow us to use a MAC address that does not belong to a particular port. It could be shared amongst ports. It could be something which is a property of the switch. And this would allow us to have an off-box entity like a SDN controller to be able to program what MAC address is accepted for L3 forwarding. And analogously, the transmitting switch would then use that MAC address as the DMAC to reach us. So this kind of got us to have this state be programmed from the SDN controller and not have to rely on control plane to discover the peer's MAC address to be able to send to the peer. To to achieve this, we defined a new SAI object of the type MyMAC, and the attributes are some of the attributes which are used on the router interface's ingress processing, namely the port, the VLAN, and the MAC address, of course. We see this object as independent of RIF programming. So the RIF programming would happen just as it is done today. This object is something over and above, so it will add additional entries to the MyMAC table, wherein the router interface programming is also adding. We just think that these entries are disjoint and they should not conflict with each other. Now I'll go to the third part of the presentation.
Kishore, I just want to highlight a few things.
Sure, go ahead.
So on the MyMAC side, what Kishore was pointing out, so RIF has got a MAC entry, and then that will also populate into the MyMAC. And it's up to the controller, to the SDN controller, to make sure that if there is different behavior expected, then the RIF MAC is different than the MAC which is programmed into the MyMAC table. The tool chain does not provide any kind of support because it's a dynamic information which is present, the intelligence is present with the controller. So in the SAI tool chain, we cannot take that decision. So it's very much possible that you can program invalid entries into the MyMAC table and tool chain will not detect it. So control plane must make sure that the entries are programmed correctly. That's one thing. And on the pre-ingress table, it's a very subtle point. Right now, the keys and actions, they are a union of all possible stages, correct?
That's right.
Right, and toolchain does not provide that this QSET is applicable to this stage or that stage, and that is left for the implementation. And the reason, again, because the intelligence lies with the controller, not with the SAI data plane. Those are the few key points I just wanted to highlight.
Yes, those are good points. Yeah. And with respect to possibilities of conflict between controller programming MyMAC entry and a router interface programming a MyMAC entry, the intent is that the router interface MAC addresses are bound to ports and they will come from a certain range, correct, whereas the controller's entries will be coming from a disjoint range. And since the current action is essentially admit to L3 processing, there's no conflict. Right. So they are pretty much, having the same action as of now. Great. So I will go to the talk on the FEC extension that we have.
Hello, my name is Mike Beresford, and I'm here to talk about our third and final topic for this session, which is forward error correction, or FEC, for 200 gig and beyond speed ports. Just for background, forward error correction allows the receiving end of a link to perform correction for a limited number of errors without requiring retransmission. At speeds of 100 gig and under, FEC is optional, but as we move to higher speed, transmission has become a required part of the specification. The SAI interface does support FEC, but the options were previously limited to 3 settings. You can turn it off, disabled. The second one was fire code, or FCFEC, which was used typically at lower speed, like 40 gig links. And then the last is Reed Solomon FEC. So fire code and disabled are relatively unambiguous. You can have it disabled, you can set fire code, there's no configurations for it. But there are multiple variations of Reed Solomon FEC that may be configured based on the configured port speed. And there may be multiple variations even allowed at the same port speed. The vendor SAI implementation would be required to select the correct configuration automatically with no control available to the NOS. So just set RSFEC and it would select the appropriate Reed Solomon FEC configuration. But the problem we run into is, as shown in the example here, 200 gig PAM4 links support both RS544 and RS544 with 2x interleave. as valid options, but the API lacks a way to specify which one to use. Different vendors may select different behavior here, and if that were to happen and you had them on the same link, the link would not come up. The FEC is incompatible, and it just would not work. So what we did was we added a change to the SAI specification to allow the explicit configuration of the Reed-Solomon FEC type. It was not practical, unfortunately, to modify the existing FEC configuration to allow explicit configuration of the FEC type because the existing NOS may depend on the current behavior. So what we did instead was we introduced a new SAI attribute to the port, which allows configuration of the extended FEC type, which allows setting the new attributes as well. As with the existing FEC configuration attribute, it allows setting fire code FEC or disabling the FEC, but as you can see here, it also specifies or allows specification of the detailed RS FEC mode. Additional modes can be added as the community requires, but what's present today are RS528, RS544, and RS544 with 2x interleave. So additional ones could be added, and also different FEC types could be added as required. So just going into some use cases for this, if we talk about how we would use it for the 200 gig use case we discussed earlier, the NOS may now explicitly configure the RS544 or with or without interleave. And since it's under direct NOS control, there's no longer any ambiguity about which FEC mode would be in use, provided the vendor SAI supports the extended FEC configuration. Another use case we came up with here is for a gearbox optic to a legacy platform. So as an example, we might have a system that uses 4x25 gig lanes going to an SR2 gearbox optic. And that 4x25 gig would typically only support RS528. In fact, it wouldn't support RS544. And if the remote side was using 2x50 gig lanes to like a 400 gig SR8 optic, that would typically default to RS544, but might support RS528 as well. So what we would do in this case is set the 2x50 gig side to use RS528 FEC as opposed to the default of RS544, and that would allow us to bring the link up. The pull request that was used to add these settings is listed here, so you can follow this link if you would like to see the details of the pull request, and it is merged as part of the SAI 1.9 specification. So if you have any enhancements or suggestions, please bring them to the SAI community at the weekly SAI community meetings or pull requests, or send an email to the mail list. With that, I think I will hand this back over to Jai and Kishore and for the closing of this session. Thank you.
Thank you, Mike. Jai, do you have anything to close on?
Yeah, so I think as we talked about earlier, we did the heavy lifting of getting the agreement of adding these blocks into the SAI logical pipeline. So they are present, and by no means they are complete. The QSET and the actions can easily be enhanced. As Kishore mentioned, Google's use case was more specific to VRF. That's what we started with. Same thing on the MyMAC table. There was a very specific use cases for the DMAX allocated by the controller. That's been added, but does not mean that it cannot be enhanced. The basic plumbing is there. Now it's very easy to enhance. So if there are additional use cases in terms of adding more control on the MyMAC table or on the pre-ingress stage of the ACL, please bring it to the community. It's very easy to do that now. All we have to do is agree on a given QSET or the action type. Kishore.
that was a good summary. Thanks.
Yeah.
Are there any questions from the audience?
So if there are no questions, then we will close the topic. Thank you.